Hi. First of all, thank you all for being here this morning. I know it's a hard morning after the party last night. I'm going to talk to you about detecting phishing from passive DNS, and I'm really happy that you're all here. Just for a quick recap, who here knows what passive DNS is? Okay, we have like 10 people. That's a good start. So first of all, who am I? My name is Irena Damsky. I'm an Israeli cybersecurity researcher. I've, I have my own company. It's called Damsky Tech. You're welcome to visit our website. I have a few years of experience in the industry. I ran security research for a startup based out of the US. I used to work for a checkpoint, and I served approximately 10 years in the Israeli military, in the intelligence forces. And it, also, I'm on Twitter, I'm on LinkedIn, LinkedIn, whatever. I don't know what word you use for LinkedIn, so link in, whatever. So, and this is my pet unicorn. I have a few of them, so just be nice to them. First of all, phishing. Sorry, it's quite bright. So, who here does not know what phishing is? Okay, that's a very good start. Everyone pretends to know what phishing is. But in case you're just pretending, let's look at the dictionary. I'm sorry about the colors. Let's look at the definition from dictionary.com. Based on this definition, it's the fraudulent practice of sending emails perpetuating to be from reputable companies in order to induce individuals to reveal personal information such as passwords and credit card numbers. Have you ever gotten a phishing email? Okay. Have you ever clicked the link? Okay, at least someone here admits that he did, because most probably we all did. They usually do it in a pretty decent way, and I'm not asking if you click the link inside your malware lab, that's not interesting. But honestly, a lot of time it does look like something that might get us to click the link, because it usually looks like something that is supposed to look like something you want to click on, right? So it might look like a page that looks exactly like the secure login, but if you look at the URL on top, on the domain on top, yeltrend.com is not actually Dropbox. Or in this case, another signing screen for Yeltrend. This is actually an email. Both those screenshots were from a phishing scam that was running around last Saturday. So a lot of times it looks like it, but it shouldn't look like it. So remember that. Sometimes the content is very, very different from the domain that is actually used for the attack itself. So DNS. Who here doesn't know what DNS is? Okay, good start. So DNS is the domain name system. It's not the domain name server, it's the domain name system. So when I say DNS server, it's actually legitimate. I'm not repeating the same word twice. It was first introduced in an RFC from 1983 by Paul Mokapitras, and since it was updated a few times, it's mainly UDP traffic on port 53. It's mainly because there are some traffic that goes over TCP, there are alternative ports. So if you're trying to sniff your network and find all the DNS traffic, you should basically look for everything on port 53 and not limit it to just UDP. And it's basically used to translate domain names into IP addresses and making your life easier. What can you do with it? You can assign friendly names to IP addresses. Chances are you're not going to remember the IP address of my website, but if I repeat damsky.tech enough times, you might remember that, and you might even wind up going to my website at the end of this presentation. You should. You can create commercial or non-commercial entities on the internet that are then used to attract people. You can become a registry or a registrant, and you can buy, sell, and auction domain names and make money out of it. And on the other sides of it, you can share the information that you get from your DNS traffic with friendly or less friendly entities. So you can share it with governments, you can share it with customers, you can share it with other partners that will possibly or probably track you and do things with it. So maybe GDPR will help you a little bit with it, maybe not. GDPR for the win. Uh, and you can use this data to build your products. So if you have your own DNS data, you can use that in order to protect your organization using your own data. And this is actually what we're going to be talking about later on in this presentation. Just a few definitions. An FQDN is a fully qualified domain name. Every FQDN is unique in the IP space. In the domain space. So it's only one fully qualified domain name that looks exactly like this. And it has several parts that are part of every domain name. So going from the end, at the end you have the dot. It's usually omitted because it represents the root servers and it's in every domain name, so we don't bother. Then the next part is the TLD. It's the top level domain, and it represents the big chunk of information and what root server you should be accessing to get the information about. Then you have the secondary domain, and that would be the actual website you're trying to access. And then third, fourth, fifth, 10th level domains, and it's the lowest and most left-hand label of the domain. Those are the host or the subdomains. So basically, a domain is a collection of labels separated by dots. And if you look at www.domain.com, www, domain, and com, each of those are a label. If you look at the last part, that would be the tld.com, or you can sometimes even see stuff like .com.br, so it's a public suffix that although the secondary level domain is, it behaves like a TLD. There is a full list of those, it's accessible, and I have a link later on in the slides. Then the next part is the SLD, the secondary level domain. In this case, on the bottom case, it's actually the third level domain, but it behaves like an SLD. It's the important part of the domain. And then you have the subdomains or hosts. So what is a domain basically? A domain is a sequence of 8-bit value, and every 8-bit value is valid for it. So you can use any character you actually want to use. As long as you remember that on the SLD, underscores are prohibited. On the lower levels, on the subdomains, you are actually allowed to use underscores, although it's not highly recommended. Also, there are some TLDs that prohibit use of IDN characters, so international characters. So sometimes you can not use those in the primary domain name. On the wire, in the wild, domains are allowed to have up to 256 characters, and each label is up to 64. So you cannot have stuff that it's extremely long. And as I've mentioned before, there are some public suffixes that behave like TLDs. There is a full list of those. You can find those, you can use those in your systems. It's awesome. And IDNs, international domain strings, those are translated in our logs into regular ASCII, and those will always start with XN dash dash. So if you're seeing something like that in your log, it means that it actually had a character that's not a English or a Roman character. Sorry. Let's talk about TLDs. GTLDs, the generic TLDs, the ones that we all know and love, are .com, .net, .edu, have been with us forever. And a few years ago, new GTLDs were introduced, stuff like .tech, .paypal, .moscow. You can actually register a TLD for your business. So for example, PayPal might one day register PayPal. And when I say one day, it takes about 2 years currently to approve a new TLD with ICANN. ICANN is the organization that runs the domain system. And they are working on it. And hopefully, once PayPal will finally register that TLD, they'll start sending emails from customersupport.paypal instead of paypal-customersupport.com, which looks like phishing. Then those are the new ones. You can apply for them and you can get those. The CC-TLDs have also been around for quite a while. Those are country code TLDs. You have .pl, .nl, .cc. .cc is for Cocos Islands. It's actually a legit country, not just a spam trap. Sorry. And you have the IDNs. So stuff like Hong Kong and Egypt, Asian scripts, Arabic scripts are the most common ones that use IDN domain names. But it's also available in Cyrillic scripts, in Hebrew scripts, and in any other language that you want. So finally, we're getting somewhere. Passive DNS. So passive DNS was invented in 2004 by Florian Weimer, and it's basically a historical database of your DNS resolutions. So the way you collect it is basically not asking a DNS server for a resolution for a given domain, but you are looking at stuff that people asked in the past. It's usually collected using multiple sensors on the internet, and it is, as I said, passively collected. So it means that if there are domains that are not accessed, it will not be in your data set. If there are domains that are not accessed from a point that is covered by a sensor, it will not be in your data set. So, and that's also the reason that the data changes based on the database that you're looking at. So if two different vendors or two different collections look at this, the internet traffic, it will be built using their sensors, and those sensors based on geographical locations or user behavior will be different. As an example, I'm sorry about the resolution. It looks better on my computer. So this is an example for my website. I took it from Passive Total the day after I registered my website. And although Circle LU Passive DNS is marked here as one of the sources that Passive Total should be looking for the resolution, it has no hits. So no one from Luxembourg accessed my website in the first 24 hours. It was a very, very hurtful truth to find out. I told the few people I know in Luxembourg that that's not okay, so they went to the website. The next day it was fixed. So if you if you look up my website on Passive Total, it's okay now. But on the bright side, I got a slide out of it, so everything's all right. So ways of collecting passive DNS, and this is something that we should remember because you can do it at home. You can do it on your own network. So one way of collecting passive DNS is using sensors that you set up in the network. And in this way, you usually place those sensors above the recursive resolver. That way, you will not get the source IP of whoever made the query. So if you're looking within your organization, you don't really care for passive DNS who is the user that was looking at a specific website. What you want to know is at a given time, what the resolution, what IP he got, and what server he queried. So usually it's above the recursive resolver. It is only cache misses because the recursive resolver saves a lot of data in its cache to save on traffic. You only get live traffic. So again, as I've mentioned earlier, if no one went to that website, it will not be recorded. If no one opened the phish email, were you phished? So, and the first time that you'll see something in your data set will be the first time that someone actually went to that website. The other way of collecting passive DNS, and it's less common, and it is also used by some of the vendors, but it's not something that I would recommend doing at home, is collecting passive DNS using scraping of zone files. So every time a domain is assigned a new IP address, the zone file for the DNS servers is updated and the information is recorded on the servers. So if you're going to scrape those servers, you will be able to get that information. In this case, you are not connected to user traffic. So basically, in this case, every domain that was assigned an IP address will be recorded in your passive DNS collection. On the other hand, you will only be getting information from the TLDs that are publishing their zone transfers. So the generic TLDs, both old and new, are regulated by ICANN, and they are obligated to publish their zone transfers. And every time they update a zone, that is released. CCTLDs are actually some sort of wild, wild west. They are not obligated to do that. They have a little bit different restrictions than the regular TLDs. So approximately half of them do not comply with this rule of publishing all zone transfers. So you will not be able to use this technique on all of them. Also, another problem with using the zone file scraping as a passive DNS collection method is the fact that you can only collect information from the first and secondary servers. So if I'm using a local name server, I'm not obligated to publish the zone files. So you will not be getting information about subdomains and subdomains. You will only get those on the primary domains, and that's about it. So in this case, though, you will be getting information about the domains based on updates that are actually happening. So once the webmaster or the domain master reassigned the address to a new IP address, that will be logged in your database, and it has nothing to do with user traffic. So there is a benefit on that side as well. But again, you will also be getting information about the domains that no one actually accessed. So it's like blog posts. Basically, if I wrote a blog post, it's out there on the internet, no one read it. Is it interesting? So it's the same thing here. First time is the time of mapping, not the time of access. So two different methods, and it's important to remember both of them. If you don't want to collect your own passive DNS, you can buy it from a variety of vendors. Farsight, RiskIQ, NetLab, all of these vendors give a little bit of a different data set. Some of them do not sell it as a data set. They give it access to researchers, but for example, NetLab, the 360, gives their data set based on the fact that they collect mainly Chinese traffic is very different from the data sets that you will get from other vendors. If you don't want to pay for it, you can actually build it at home, do it yourself sort of a way. Just get a lot, like a shitload of storage. If you're trying to do that, you have to scrape all of your port 53 traffic and all of your DNS server logs. And once you do that, you save into your database tuples of domains and IPs per time span. So first time I saw this domain resolved to this IP was at X 100 hours in whatever timestamp, and the last time I saw it on this timestamp was at that time, and every time it changes, you add a new tuple. Additional information that you'll want to probably save is what domain DNS server gave me this information. Because if I got this information from Google, or I got it from Quad9 or from Cloudflare, and they gave me different results, that's interesting. Another information you'd want to know is where did you make this query from? You don't care who the user is, but it's interesting to know that if you're making this query from China or from London or from the US, you're getting different results. So that's also a metadata piece that you might want to keep. So now that we've covered both phishing, because we all knew what it was, some DNS magic and some passive DNS, let's talk about symptoms of phishing. So I'm going to give you a list of symptoms that we're going to talk about each and every one of them. So I'm not going to stay long on this slide. So let's move on. And basically, before I go back to the symptoms, I just want to say this whole research was made possible thanks to access to the Farsight data. And what I did is basically I queried that data with a label for Microsoft. So I was looking for all the domains that are Microsoft dot something, everything that starts with the word Microsoft. I wasn't looking for stuff that has Microsoft somewhere in the center, only the beginning. And I limited my search for the past 24 hours. I got almost 7,500 domains. Guess what? Microsoft doesn't own 7,500 domains with the word Microsoft that are accessed on a daily basis. So let's just look at it. Basically, the first symptom of phishing is when you have multiple labels, multiple sublabels. So once you have more than 2 subdomains or sub-hosts, that's already a bit fishy or a bit suspicious, because most domains or most legitimate services usually use only one. So you'd use www, your website, or blog, your website, or something, your website. Maybe sometimes you'll use 2 sublabels, but that even that's not common. So 2 is already a little bit suspicious. If you have more than 5 of those, that's likely a phishing website, or not necessarily phishing, but something malicious. If you have more than 10 labels, I put it in the category, I've never ever seen it being non-malicious. I caveat that. Sometimes I've seen those things being non-malicious, but they are erroneously created by scripts that people write. So sometimes that happens. Once you do that, you have to remember that you also have to whitelist the results, because there are websites that actually give you results on your queries by appending your query as a sublabel. So in this case, WhoisBucket is a service that gives you information of Whois information for domain names, and it does that by appending the domain you asked for to the beginning of your website. So Microsoft COIL is actually a legitimate Microsoft website that is used in Israel, and WhoisBucket is returning the information. So once you look at that, you see, okay, WhoisBucket is legitimate. I'm going to whitelist it. I'm not going to look at it. The next example will be repetitive labels. So if you see the same label over and over and over again, there must be some reason for it. I'm not exactly sure where it is, but it's usually malicious. As examples, there's this wonderful thing of microsoft.com.error.bluescreen.critical error, don't touch your computer, it may get crashed. And that not only appears like as a good example for the previous symptom of multiple sublabels, but it also appears twice. So I have nothing to say about that, but shrug. Another example is the Microsoft ASP.NET, something Microsoft ASP.NET.team. So we have the same sublabel or sequence of sublabels, and it is a phishing domain. Again, com appears multiple times in the bottom example. That shouldn't be happening. That's a really big symptom of something going wrong with that domain. Suspicious TLDs. So, well, there are TLDs that are prone to have more maliciousness in them. We know that. And it happens both on new TLDs that sell you domain names that you can buy and register for 1 cent per year. And it happens also on some of the legacy and old CCTLDs. So as examples for the CCTLDs that are prone to that would be IN for India or Russian TLDs. And then there is also, as I said, the example of new TLDs. So when I was looking at the domains that I grabbed from the passive data, I got 7,500 domains. 172 of them were with XYZ, 163 with download, 138 with review. And here's the example of review domains on the left. None of those 138 domains was legitimate. So it's a good sign if you're giving scores to domains that if it's using a new TLD that's prone for maliciousness, and sells domains for cheap, it might be malicious. So as an example, .tech sells domains for 40 bucks a year. It's not very cheap and it's not very worth your while to pay that much money for a domain for phishing or for CNC that will be taken down very quickly. So you can actually give scores on to the TLDs based on their prices. The next thing I'll mention would be -n TLDs. So actually, TLDs are usually either if a word and do not contain any characters other than actual letters. But sometimes you actually see in a domain name com-something or de-something. And that is, in my opinion, only there to make people get confused and believe that that domain is actually legitimate while it's not. So if you see stuff like microsoft.com.de, if it would have ended there, that might be a legitimate website. But microsoft.com.de dash flu9, whatever goes on, that's not. So just imagine that a lot of websites are actually using, for example, Microsoft.com. Romantic. So a lot of websites using stuff like Microsoft.com slash and then the path for the URI that you're accessing. Just replace the slashes with dots and then use something like Microsoft.com dot something dot something dot something dot something dot something dot somedomain.com. A lot of people won't even notice that their URL was transferred into a domain name. And when I'm saying a lot of people, I mean my grandma. I'm not saying it that technical savvy people won't. You might not. It's designed to confuse you. But a lot of normal users will definitely fall for that type of decoy. And I actually did leave the microsoft.com-maliciousattack.info because it's just a lovely domain name. And I think that they say exactly what they are. So it's a great example. So the next one is DNS Twist. And actually, it's an algorithm or a tool that was developed by a Polish guy who is not here right now, unfortunately. But it includes also typo squats. So basically, it's a GitHub repo. It's on GitHub. It might be on Microsoft.com in a few weeks. So I don't know. But you can go and download that, and it's a really, really cool tool that checks a lot of permutations for your domain name. So it will try to add letters to it. So for example, it will check Microsoft A, Microsoft B, Microsoft C, Microsoft 7, and check if that is registered. It tries to omit letters, and maybe some people will try to access MSoft, like Microsoft without the I, because they forgot to type it in. And if that's a website, then they might actually get there. It tries to switch letters and use TF instead of FT and stuff like that. It uses typo squats. So the fact that the screen is not very sharp at the moment, it's actually really good for my example, because it makes the RN look like an M. So suddenly, if you have ever tried to go to a website, RN iSoft, you actually get to a fake Microsoft website, or you used to at least in the past. CL looks like D, CJ looks like a G, and so on. We all know the 0 and O substitution, but VV actually turns into a W. Who thought about that, right? So those things are actually very popular and are actually used in quite a lot of domain names. And there is actually a feed that's available for Vistaprint domains that used to have like on a daily. So Vistaprint was a registry that allowed you to register a domain name for free for the first 30 days They did not ask for your credit card info. They did not verify your name. They did not verify nothing. They just told you, okay, get this domain name, and after 30 days, pay for it. Guess who used it? So they had like thousands of malicious domains, thousands of typo squats registered on a daily basis. So there is a feed that's actually looking for those and sharing those. It's available online. Um, so DNS twists, typo squats. Here's an example. This is also an example from last Saturday, so May 26th. It's very new. But Twitter, and in this example, the I has two dots on top and the E has an accent. Some people won't even notice the difference when they're looking at the domain name in a URL. But once you click on Twitter and you get a screenshot, like you get the login script to LinkedIn, you should be suspicious. Like, you already thought about getting a really, really good decoy as a URL. Do your work, seriously. And that's been the example that I was heading to, and that's mixture of scripts. So basically, most cases you use only one language for when you type in a domain name, so it will be like Latin letters, or you can use IDN domains, so you can use Japanese, Chinese, Arabic, whatever. A lot of times you see eBay with an accent on an E. That shouldn't happen. That is already a sign that this domain might be malicious. So in far Asian countries, in India and Japan, stuff like that, they do actually use both English and Japanese characters and both Indian characters. It is something that happens. It's not very common. So for me, when I'm automating this whole thing, if I see two different scripts within one domain name, I'm giving it a suspicious score. And here are more examples that you can't actually see because of the resolution. I'm sorry. The slides will be available later. You can check it out at home. So another example for some typo squats that I got really mad at is basically on Disneyland, because there are things you shouldn't be yeah, you shouldn't be phishing, you shouldn't be scamming, you should not be hacking the database for, or leaking the database for the Hello Kitty fan club. It's like, it's just mean. So same here, if you're hacking the Disneyland or phishing the Disneyland Paris website, I kind of hate you. But I also want to show that I can't show this for some. Can this? Oh, boom. So there are multiple different twists that you can have for Disneyland.com, and most of them are not yet registered. So if you actually want to fish Disneyland, go ahead. Yeah, dozens of those. And if I'm, this one is actually is Disneyland. So if you want to go to Disneyland, it's available on this website. This is the name server, and this is the output of the DNS twist algorithm. So just wanted to show that. So, once you get all those scoring features, you should give those some sort of a score. You can give the suspicious like 10 points, the likely you get 20 points. The category of there is no way in hell that's not phishing will get 50. And then you sum those and you get a score, and suddenly you just look at the results and like, yeah, this is phishing. Like, it has to be there. There's no other option. But sometimes, as I said, you also have to look at those things and remember that things like whois bucket should be whitelisted. So before you actually go ahead and block those results on your network, look at them, at least for a while, at least at the beginning, and check out what you're getting. Um, don't forget that this whole thing, I've started it based on a keyword. So I already started it with using the word Microsoft. If I were to start by looking at things only based on the features of the domains, so I was scoring the labels, I would be scoring the TLDs, and I did not have a label that resembles the word Microsoft, that would have an initial lower score. So if you have a dictionary of brands that might be phished or scammed, that already gives you a good starting point. So if you're looking for scams about your organization, that's where I'm heading. Um, some future work that's relevant for this is, for example, implementing machine learning on it. And once you implement machine learning on these features, you will be able to catch stuff that is not based on a specific label. But I also want to stress out that you don't have to use machine learning. Machine learning is a cool and awesome technology, I'd say, but this is a very simple thing that you can do on data that you have within your network. And you don't have to overcomplicate everything. We love overcomplicating things in security. We're researchers, and we feel that if we do something difficult, then we won. We don't have to. Sometimes the simplest thing will get you to the best results. So just think about that when you're designing a system. It's interesting to also follow up on the clusters behind that information. So I got a lot of different domains. If I'll check to which IPs they resolve, and I see that I have a bunch of IPs, domains that result to same IP or the same network or the same AS, that's a sign that that IP or AS are prone to maliciousness, and maybe I should block that. And maybe new domains that will be registered and pointed towards that IP should already be marked as suspicious. It's also true about name servers. So it's much easier and much cheaper to buy domains, dedicated domains. If you're buying a dedicated name server, that's expensive. That is not something you throw away the next day. So a lot of times, specifically in the example of DGA domains for malware, the name servers are dedicated. So once you figure out on a DGA what name servers are used, you can block those, and then all of the future domains from that DGA will be blocked. That's a pretty neat feature, because in that case, instead of blocking hundreds and maybe thousands of domains that change on a daily basis, you just block one name server, maybe two. Well, two, because you always have a primary and secondary. But the sizes and the amount of rules that you have to control are much smaller. You also can follow up on whois, or you could until last week. I'm not sure what we will be able to do with whois information now with GDPR, but it's going to be interesting. So actually, so far, ICANN said that registries are still obligated to collect whois information, but actually a registry from Germany announced last week that fuck that, we're not going to do that. It violates GDPR. So there's a lot of discussion about it, and I can actually submit a lawsuit about that, because you have to have information about who registered this domain. And this information might not be available to the public, and you might be obligated to handle it with a specific care and with specific love and emotions, but you have to collect that information. So since this registry decided that they're not going to collect this information, they are already being sued. So we'll see. I'm like following up on that with some popcorn, and just let's see what's happened. So this research was done solely on DNS data. But what happens if we actually look at those domains that we caught and actually go and scrape the web page that's behind them? Can we see interesting elements that are collected from there? So just as an example, but if I'm using Google Analytics trackers or cookies, and I've used it on one bad website, every other website where I'll use it is probably going to be bad as well. So it's also a very interesting part of the content of the web page on the phishing or CNC site that I would like to follow up on. I'd also like to see if, based on the DNS data that I've collected, can I actually do some attribution and can I actually find who's behind this? So just as an example, so I've seen specifically in this example, I've seen a few dozen domains that had the same beginning. So I'm not saying like Microsoft.com. I'm saying Microsoft.com.label.label2.label3, something random. And I had like a dozen of those. And what I know is that all of those domains belong to the same phishing kit. So basically, it was hard-coded within the actor's code and within their system to use that substring as a subdomain, and all they have to do is just change the domain that they're actually registering once their domain is being compromised. So we've been doing this research for years on the URI part. So we know that a lot of CNC servers use the same exact URL but only change the domain name. Are they doing the same on the domain but on the other side, on the left side instead of the right? Spoiler alert, they do, and we should follow up on that. Sorry. And again, it's the same thing. Can the phishing kit be recognized based on that data and not only the actor itself? So that's basically it. It's a pretty simple technique to find maliciousness using a pretty simple data set that we all can collect or buy if we want. And I hope you enjoyed it. Thank you. Questions? Yep.
A website, but on the cloud infrastructure, then what would you recommend to use as a passive DNS?
So passive DNS is actually a collection of resolutions. So not exactly sure what you mean, but it's basically who tries to access this domain. So the resolution of a domain to an IP, you need to be somewhere in the middle between the user who asks for this resolution and the DNS server.
Yeah, indeed, but is there any, I don't know, cloud service that will give such possibility? So if my, let's see,
Like,
my domain is in the
yeah.
CDNs, then...
So basically, you have platforms like Passive Total that give you access to different passive DNS databases, and you can query them. I think this is what you mean. I'm not sure. Let's talk about it later. I'm just not following the question.
Thank you.
Thank you. Anyone else? Thank you. Have a great lunch.